This video is part of IPC's series on hand soldering. During this program, you will be shown the techniques for hand soldering wires to a variety of terminals. A terminal is a metallic connection device that is used to terminate a discrete wire or wires. The terminal provides both a mechanical and an electrical connection. There are several different types of terminals, each requiring specific hand soldering techniques. We'll be examining turret terminals, cup terminals, bifurcated terminals, hook terminals, and pierce terminals. For an overview of the tools and materials required for basic hand soldering, as well as safety and handling considerations, refer to IPC video VT12. A hand soldering iron with interchangeable tips will be used. There are conical tips and chisel tips. Conical tips are round and chisel tips are flat. We'll be using chisel tips because they have a flat edge. The flat edge transfers heat faster and more efficiently due to its mass and greater mechanical contact. The first step is to tin the tip of the iron, which will reduce the formation of oxides on the soldering iron tip itself. Tinning the tip is an important quality process control step to ensure the soldering iron tip will wet with solder and is fit for use. Oxidation acts as a barrier or an insulator, which means it slows down the transfer of heat. Tinning the tip with solder also enables the heat to transfer from the tip to the connection faster. In addition, the insulated wire needs to be stripped and tinned prior to attachment to the terminal. There are many ways of stripping the insulated wire. Some methods are unacceptable because of possible damage to the insulation and the wire. The safest method is the proper use of the thermal stripper, which melts or softens the insulation. Use your fingers to twist the insulation slug off in the direction of the wire lay. Do not use the stripper to pull off the insulation slug, as it can potentially damage the wire. The stripped wire now needs to be tinned. This is done so when the wire is bent it won't be damaged, and to improve solderability. To tin the wire, you can move it across a solder-coated iron tip. Move a tin tip over a stationary wire, or dip it in a solder pot. Before we begin soldering terminals, it is important to clean the soldering iron. A clean, damp sponge should always be used to thoroughly clean the tip. Never use a wire brush to clean the tip because of the possible safety hazard of splashing hot solder into someone's face, hands, or clothing. A wire brush can also damage the tip of the iron. And when you're finished soldering, always give the tip a fresh coating of solder to cover the tip. Tinning allows the tip to last longer because it forms a protective barrier. The first terminal we'll be soldering is the turret terminal. Because the wire will be wrapped around the turret, the tinned end is now formed into a loop and the loop is cut. The wire then can be placed in position on the turret terminal. There can be different degrees of termination of the wire wraps. These will be based upon your company's specification. Common sizes are 180, 270, and 360 degrees. A 270-degree wrap or greater will decrease possible wire movement during the soldering process. If one wire is to be connected, it should be placed on the lower section of the terminal. It should lay flat against the base so that any mechanical stress will be transferred to the board rather than tending to tilt the terminal and perhaps damaging the pad. With two wires, they should both be brought in from the same side so that the insulations touch. This will leave a gap between the stripped areas of the wires. The gap allows for easier inspection of the solder joint. Now let's take a look at the proper way of soldering turret terminals. The soldering operation consists of 4 basic steps. First, the iron should be placed in contact with the wire at the point of greatest thermal mass. This is called the contact point. The solder is added at the contact point to form a solder heat bridge. The purpose of the solder heat bridge is to transfer heat more rapidly to the solder fillet area. Additional solder is then applied on the opposite side of the point of contact to form the necessary solder fillet and removed. Then the iron is withdrawn at the same angle it was introduced to the joint. Let's watch the entire operation once again in real time. Do you know how to determine the correct amount of solder? What exactly do you look for when assessing a solder joint? First, we'll remove the flux to examine the joint. The cleaning requirements are the same as any other hand solder connections on a circuit board. Some companies use low residue or no clean fluxes, which may not require cleaning. It is important to adhere to the manufacturer's specification for solder temperature and cleaning requirements. Your company will supply you with a compatible cleaning solvent and instructions for its use. They will make the decision whether to clean or not based on customer requirements for reliability or cosmetic quality. Once the flux is cleaned, we check that the solder is feathered out smoothly, showing good wetting action over all elements of the joint. Wetting is the formation of a smooth, unbroken, and adherent film of solder to the basis metal. This area is called a fillet. On a proper solder joint, the solder fillet is slightly concave or curved inwards. When there is insufficient solder, the joint may not have acceptable mechanical strength. When there is excessive solder, the fillet will be convex, and the outline of the wire will be buried in the mound of solder. This can also hide defects in the internal connection. It is important to solder so that the joint can be visually inspected. Soldering for inspectability means you're always able to see the outline of the individual strands of wire in the joint. Let's stop for a moment and review the information we've covered so far. The next type of terminal we'll discuss is the cup terminal. The cup part is a hollow cylinder. The wire is inserted into a prepared cup and soldered. For these terminals, the cup will be pre-filled with solder. This is done because one of your hands will be holding the soldering iron and the other will be holding the wire. Pre-filling provides a consistent quantity of solder that is repeatable for each soldering operation. In the cup preparation process, an important step is to use the proper quantity of solder. Now let's take a look at the proper way of soldering cup terminals. The pre-tinned wire is first inserted into the cup to measure for correct wire length and insulation clearance. For minimum insulation clearance, the insulation may contact the top of the cup but not interfere with the solder wetting to the inside of the cup terminal. Maximum insulation clearance should be less than 2 wire diameters, including insulation, or 1.5 millimeters, whichever is larger, but shouldn't permit shorting between adjacent conductors. In this case, the insulation clearance is excessive and should be corrected. Next, the cup should be filled with solder. Multiple strands of solder are twisted together tightly and inserted into the cup, or a single strand of heavier gauge solder can be used. This is called a solder pre-fill and should be cut off flush with the top of the terminal. This is done to avoid spilling solder on the outside of the cup. Different sizes of solder and the tightness of the twist can change the result. The soldering iron is now held on the terminal until solder flow is observed. Notice that a solder heat bridge is not used for this operation because of possible spillage. Another option is to create a heat bridge by using a minimum application of flux on the back of the cup at the point of contact. This will assist in heat transfer and spread out any solder left on the cup from the tip into a thin film, which is acceptable. After the solder prefill melts into the cup, place the wire into the cup. You'll need to confirm that it bottoms out into the cup and is on the back wall of the cup. Now remove the iron and do not allow the wire to move until the solder is solidified. Moving the wire during the solidification process will cause a disturbed connection. The solder joint will look grainy and dull and contain minute fractures, which is not acceptable. Let's watch these steps again so you better understand the operation. First, cut the wire for a proper insulation clearance. Install the correct amount of solder prefill. Heat until solder flow is observed. Install and position the wire. Remove the iron and hold the wire in place until solder solidification. If excessive solder is used, it will spill down the sides of the cup. If insufficient solder is used, there won't be the minimum mechanical strength required. Here is what the acceptable solder joint will look like. The wire is fully in the cup and there is an insulation clearance from the top of the cup to the insulation of the wire. The solder contains no pockets of flux or gas trapped within it and hasn't spilled over and down the sides of the cup. Also check that there is no buildup of solder on the cup where the soldering iron made contact. When the solder volume is correct, the fillets are slightly concave and show good wetting on all the surfaces. Although you should always be aiming at making the best solder joint possible, there is a certain window of acceptability. For example, the minimum solder quantity is dependent on your company's workmanship specification. The maximum acceptable solder joint would reveal fillets that are no longer concave but are beginning to bulge. In situations where the cup terminal is inside a connector, the soldering operation is much more difficult. The area you'll be working in is much smaller, and there is the danger of possibly burning or damaging adjacent wires. In this case, a resistance soldering tool can be useful. This tool contains a pair of electrodes that can grip the cup and send current through it. The electrical current will heat up the metal and melt the solder. The manual for the resistance soldering tool will specify the correct setting based upon the type of terminal you're soldering. The advantage of this tool is that the electrodes can be positioned before the heat is turned on, so there won't be the potential damage of heating the wrong area. The cup containing the solder is gripped with firm pressure and a foot switch is depressed to start the heat. When solder flow is observed, the wire can be inserted. Then release the foot switch, and after solder solidification, remove the electrodes. The foot switch should always be released before the electrodes are removed to prevent arcing. Electrical arcing could damage the plating on the terminal. Let's stop once again and review the information we've covered in this section. Now let's take a look at bifurcated or forked terminals. On these terminals, the wires can enter from the side, the top, or the bottom. Side entry is commonly used when one or more wires are terminated. The wrap you'll be making to attach the wire may be 90 or 180 degrees. 180 degrees is used when additional mechanical strength is desired and when there is sufficient clearance between adjacent terminals. When two wires are required, they should be brought in from the same side and bent in opposite directions. Let's watch the soldering operation. The pre-tinned wire is laid across the terminals to determine the proper insulation clearance. A 90-degree wrap is made using pliers that are not serrated so damage will not occur to the wire. The wire is now positioned and trimmed so that it doesn't protrude beyond the diameter of the terminal. It should contact the middle side and the vertical edge. Place the iron in contact with the terminal base and the wire. First, the solder heat bridge is made. Remember, the purpose of the heat bridge is to transfer heat more quickly to the solder fillet area. Then the solder is moved to the other side to form a proper solder fillet. Let's watch these steps once again. First, position and trim the wire. Place the iron onto the terminal base while also contacting the wire. Form a solder heat bridge. Apply solder to form the proper fillets. The joint can now be cleaned if required. The acceptable joint will have a concave fillet between the wire and the terminal. It should be smooth, clean, and display evidence of wetting. And the wire should be in contact with all three terminal surfaces. This joint has insufficient solder and may not have acceptable mechanical strength. Also notice that the wire is extending beyond the edge of the terminal, which is not acceptable. The minimum solder quantity is dependent on your company's workmanship specification. The maximum acceptable solder joint reveals fillets that are no longer concave. This joint has excessive solder. The fillet bulges out and the outline of the wire is covered by the excess solder. In addition to side entry, wires may also enter from the top or bottom. For top entry of bifurcated terminals, the tinned wire is bent to double thickness. The bent wire is inserted between the forks and then soldered. If the wire is too large for double thickness, a filler wire is cut to length and added to fill the space. For bottom entry, the wire is bent 90 degrees from where it comes up through the hole. The wire should then be trimmed so it doesn't protrude beyond the diameter of the terminal. Next, we'll look at hook terminals. Hook terminals are found primarily on hermetically sealed relays. The wire wrap should be at least 180 degrees. Numerous tools can be used to make the wrap for the hook terminals. One example, which we will use here, is round nose pliers. Now let's take a look at how these terminals are soldered. Once the wire wrap is attached to the terminal, the soldering iron is placed in contact with the terminal and the wire. Again, a solder heat bridge is formed. The solder is now moved to the opposite side of the iron. After the solder flows over the wire to form the proper fillets, the solder wire is removed. Then the iron is withdrawn at the same angle it was introduced to the joint. The acceptable solder joint will have the same characteristics we've seen so far, that is, slightly concave fillets and evidence of good wetting. Here are examples of the minimum and maximum acceptable solder joints for hook terminals. And these two illustrations reveal unacceptable solder joints, insufficient solder, and excessive solder. The last terminal we'll be soldering is the pierced terminal. Pierced terminals have a hole in the middle. Wire can enter from either side or from the top. The wire should be positioned to contact both the flat sides of the terminal. Let's watch the proper soldering operation for this particular terminal. Notice that it's the same basic procedure we've seen for many of the terminals. Remember the 4 basic steps of the soldering operation. The iron is placed at the point of greatest thermal mass, in contact with the terminal and the wire. Next, a solder heat bridge is made to increase the thermal linkage between the tip and the work. Additional solder is then applied on the opposite side of the point of contact to form the necessary solder fillet. The solder wire is removed when a sufficient amount of solder has been added to the joint. Finally, the iron is withdrawn at the same angle it was introduced to the joint. The acceptable solder joint has these characteristics. The minimum solder quantity is dependent on your company's workmanship specification. The maximum acceptable solder joint would reveal fillets that are no longer concave but are beginning to bulge. As you've seen, there are many different types of terminals and wiring positioning capabilities, but the same soldering procedures apply to all. We have shown the methods for soldering turret terminals, cup terminals, bifurcated terminals, hook terminals, and pierced terminals. We've discussed the importance of soldering for inspectability and how to recognize an acceptable solder joint. You were also shown what is the minimum and maximum standard for acceptability. Remember, with insufficient solder, the joint won't have acceptable mechanical connection, and excessive solder can potentially hide additional defects. The quality of every solder joint can affect the operation of an entire electronic system. Careful attention to detail will help ensure that your company's products work properly and reliably. Now let's review the information we discussed in this final section.